So we are doing our third lesson in the trig graph section, except this one has really nothing to do with graphs. I guess it just had to go somewhere, so without having its own thing. So this is a revisit of inverse trig functions, which we've already talked about, but we're going to do compositions as well. So that means that we'll do one function and then evaluate it at a specific point once we found that answer. So our trig graphs number 3 is really a revisit of inverse functions. So we'll start out with just a reminder of how we evaluate an inverse trig function using our unit circle. I think before we only did sine, cosine, and tangent, and we're going to extend it to secant, cosecant, and cotangent this time. But we need to recall first what quadrants we're going to be looking in for sine and for cosine and for tangent. So we'll just do a reminder of our quadrants that we use. Then I'll pull up the unit circle and we'll do some example problems. So these are the sections of the graph that we're going to look at in the unit circle for our inverse trig functions. I think this was the fourth or fifth section from the last unit. Do you guys remember for sine which quadrants we use when we're looking for inverse trig functions? 1 and what's the other one for sine? Remember, 1 and 4. So if you have a positive value, you're looking in the first quadrant. For a negative value, we're looking in the fourth quadrant. And remember, we don't write down like 300 or 315. We always do like -60 or -30 or -45 when you're in that fourth quadrant. So that was if it's positive, we look in quadrant 1. If it's negative, you look in quadrant 4 for sine. For cosine, it's 1 and, do you remember it for cosine? 1 and, what's the other quadrant we use? 2. So if the trig function is positive, we're in quadrant 1. If it's negative, we look in quadrant 2. These aren't like X's and Y's. This is just me marking the spot, like this one and this one. And for tangent's the same as sine. We are using quadrants 1 and quadrants 4. If it's positive, we're in 1. If it's negative, we look in 4. The reason that we do that is we want to limit our unit circle because every sign will repeat. The trig function repeats twice. Same thing with cosine and tangent. So we want to make sure that we're clear on what the number is and what we want for our answer. So we're going to find a couple of these. This is just a repeat of what we've done before. I guess I'll bring that down there. But we're going to also throw in secant and cosecant, which we haven't really talked about for inverse functions. So we're going to find the inverse sine of root 3 over 2. We're going to find the inverse sine, or arc sine, you could hear it called arc sine as well, of root 2 over 2. And we're going to find the arc cosecant of, let's go with just a -2. Oh, the second one needs to be negative. Sorry, I forgot to put the negative. -2. And for cosine, we're going to do inverse cosine of -1/2. Inverse cosine of 0. And inverse secant of square root of 2. Then we'll do tangent. So remember, if it is cosine, that's the x value, sine is the y value, tangent is your y over x. And to get your cosecant, secant, or cotangent, you're going to flip over whatever. If for cosecant, you flip over what your sine was. Secant, you flip over your cosine. And tangent or cotangent, you flip over your tangent. Sometimes I like to do the flipping beforehand. That makes it a little bit easier for you to find it. And then you're not having to do so much searching throughout, but we can try it. So we'll look at our first ones. Y'all got these written down? Almost? There. Okay. So we've got sine. We want to figure out when sine is root 3 over 2. Sine is the x or the y. Which one is it? The y value. So go to your ordered pairs. You find your y value of root 3 over 2. Did I find it? Here it is. And I write down the angle measure, and that is pi over 3. Everybody okay with that? If you're in the positives, you're in the first quadrant, you just find the y value of root 3 over 2, and there it is. Okay. All right, let's try our next one. We have sine of negative root 2 over 2. In this case, we want the negative y value, or a y value that is negative root 2 over 2. Remember, for sine, we're looking in these two quadrants. So we go to a y value that is negative root 2 over 2. Am I pointing to the correct one? Here? Okay. Remember, we don't write down 7 pi over 4. We just write down negative pi over 4. We're just going to do it from this x-axis. So our answer would be negative pi over 4. It's in the same spot if you put 7 pi over 4, but in any like formal way or that you want to be specific, that's the answer that you're going to see. So there are two ways that you can approach cosecant problems and also secant problems, and I'll show you both, and you can kind of see which one you like better, okay? This is how I do these problems. I write it out, and I go ahead and flip it first, and then I find where the sine equals that, okay? Because if cosecant is negative 2, then sine is whatever negative 2 is flipped over, or the reciprocal. So that's the way that I work these problems. I go like this. I'm going to do negative 2 over 1. When I flip it, that becomes negative 1/2. So if cosecant was negative 2, that means that sine, I'm looking for a sine value of negative 1/2. Because cosecant and sine are reciprocals. So I can flip that over. Instead of having to search for a number and then think about the flipping, I like to do that part first. So where is sine negative 1/2? Right here, which is negative pi over 6. Okay. The other way to do that is think, okay, I'm going to look for a y value because cosecant will go with the y's. And when I flip that over, I have to get negative 2. So you could go through and say 0 flipped over doesn't give you negative 2, but negative 1/2 does, and you could get it that way. Which it's easy when you just have like a whole number to a fraction, but when you start getting with square roots, it's a little bit trickier. All right, cosine of, inverse cosine of negative 1/2. What quadrant are we looking in for cosines that are negative? We're looking in the second quadrant. So cosine, we always look in this first and second quadrant. This one is negative, so we're going over here. Is cosine x or y? It's the x. So I'm looking for negative 1/2. Here it is. My answer is 2 pi over 3. With cosine, you don't have to worry about any negative angles. You just write the exact angle that's in the second quadrant. Fourth quadrant's where it's weird, but 2's fine. All right, y'all try the next one. Look and see if you can find when is cosine 0. So when is the x value 0? So where is your x value? 0. Everybody see it? And it is pi over 2. Give me thumbs up. You got pi over 2 there. That's where x is 0. Okay. All right. We're looking for when secant is root 2. So I'm going to go ahead and do the reciprocal and then find when cosine equals that. The secant and cosine go together. So let's go ahead and do that. So this is root 2 over 1. I'm going to flip it over to get 1 over root 2. What do I need to do? This isn't rationalized. I need to multiply by root 2 over root 2. So I'm looking for root 2 over 2. So since it was secant, I'm looking for when cosine is root 2 over 2. So when is cosine root 2 over 2? At pi over 4. So when you're looking at secant and cosecant, you do the inverse of those. You can go ahead and do the reciprocal first and then just find either sine or cosine depending on if it was cosecant or secant. All right, tangent of 1. So tangent is the y over the x. So we're looking for a y over x that gives us 1 when we divide. 0 over 1, that's not 1. 1/2 over root 3 over 2, that's not 1. Root 2 over 2 divided by root 2 over 2, is that 1? Yep, those are the same thing. That is our pi over 4 there. All right, now we're looking for cotangent, which is negative root 3. Cotangent is x over y, remember? So we're looking in the negatives and we want x over y. Did I find it? The first one? Let's see. Root 3 over negative 1, is that negative root 3? Yep, there it is right there. Remember, you can disregard the denominators. They're always going to cancel out when you're doing tangent and cotangent. So root 3 over negative 1 does give us negative root 3. So this answer is negative pi over 6. Are y'all feeling okay with the secant, cosecant, cotangent? Those are new ones that we hadn't done before. You're just having to flip them and then see what it would be, sine, cosine, or tangent from there. All right. So what we're going to do next is we are going to do compositions, which means they give you an inside problem to work, and then you apply an inverse trig function to the outside of it, or vice versa. We could do it reversed, where we do the inverse part and then we switch. So we're still going to use our unit circle for this part. So with our compositions, we always work from the inside out. We do what's on the inside first, apply it to the outside. So with these, we just have two problems in one. You evaluate the problem that's on the inside, get that answer, and then apply your outside operation to it. Remember, when we're doing inverse, we're looking for angles. If there's not an inverse, we are looking for the trig function, or what's in the ordered pairs. All right, so let's give this first one a shot. And then I think you could probably, well, yeah, I don't know if you can get the net. You probably could. I bet you could. So the first one, what are we working first? Are we doing the sine part first or the cosine part first? The cosine, because it's on the inside. So we're just going to write down what cosine of 2 pi over 3 is. So we just go to 2 pi over 3. Here's 2 pi over 3. Is cosine the x or the y? The x. So we just write down what the x value is at 2 pi over 3. And what is that x value? -1/2. Good. The thing froze. So I'm going to replace cosine of 2 pi over 3 with -1/2 because that's what that equaled. And now I'm going to do inverse sine of -1/2. And now these are like the ones we just did above. So we're going to find when sine is -1/2. We might have already done that one. So it's the y value, -1/2. It's right here. Remember, we don't write down 11 pi over 6. Our answer will be -pi over 6. So do we see how it's just a combination of two problems? Work the first one first, and then it ends up likely something we did before. Okay, so we'll try the next one. This one confuses people because tangent 0 is an angle, and 0 is also a trig ratio for this. So when it says tangent 0, we don't have the inverse sign with the tangent, so that just means to go to 0 degrees or 0 radians and figure out what tangent is. Remember, tangent is y over x. So what is 0 over 1? 0 over 1 is 0. So tangent of 0 is just 0. Now I bet y'all can write down your answer. When is cosine 0? Dalen said it. Pi over 2. Right. X value is 0 at pi over 2. Give this last one a shot, and then we'll see if y'all get it right. So work on the inside first. When is sine 1/2? And then figure out what cosine of that angle is. Who thinks they got it? Or y'all like, I'll wait for you to tell me the answer and then I'll tell you if I got it. Okay, that's fine. All right, when is sine 1/2? So that's our y value. Sine is 1/2 at pi over 6. We okay there? We got that part? All right, so we're going to now do cosine of pi over 6. So go to pi over 6, and the cosine is √3 over 2. Did you get it? Okay. So complete the task on the inside and then apply the outside operation to whatever that answer was. So those are the ones that you work with the unit circle. There are some that are not on the unit circle, and for those, we have to use a triangle and the Pythagorean theorem. So we just have one question left, and it's just a way to rewrite a problem that we've done lots of times before. So if it's not a unit circle, we have to use triangles for it. The setup is the same. It's still going to say the same thing, but you'll notice that the numbers aren't familiar numbers to you. It might be like 4/7, and those aren't things that you find on the unit circle. So for that, I'll just let you know what exactly it's saying, and then once I write that sentence out, it makes a whole lot more sense. These are a little different because we're not going to find the exact angle value like we would have found on the other problems. We're not going to do that. We're just going to know that these two things both live in the same triangle, right? The cotangent and sine we're going to use from the same angle in that triangle. And we don't have to actually know, is this 48.2 degrees? Is this 57.9? We just have to know that the theta exists and what the numbers are on the triangle. Okay. There are a lot of, I think there's a good amount of ACT questions like this. So expect some that are similar to this kind for your Virtual Friday work tomorrow. Y'all got about half of those ones right last time, I think, with the period questions. Was it just hard to see the graphs when you were looking at the period? Or you just couldn't, or is the graphs just kind of hard to see or figure out? A couple of you don't ever read the questions and you just go like this because you've never gotten any right. And I feel like you're smarter than that. So those of you that do read the questions and are trying to improve your ACT score, then yeah, if you have any questions about those, let me know for the period ones. I was just seeing that y'all were having trouble on the graphs. Okay, that's not a negative, that's a straight mark. Y'all got that written down. So what this is saying in sentence form is sine of theta is 3/5. That's what this means. We agree that that's what that means? The trig ratio is 3/5 of whatever the theta is. Okay, so sine of theta is 3/5. Then they're asking, what is cotangent of theta? Do problems like this seem familiar? They should be. You did them last week on your test. But sine is 3/5. What is cotangent? So for this, we're going to draw a triangle, do Pythagorean theorem, and la-ti-da. It's just the notation I wanted you guys to be familiar with. So if sine is 3/5, my opposite is going to be 3. Hypotenuse will be 5. Cotangent is adjacent over opposite, so I do need to find the last side. Sometimes you don't need to find the last side. You've got all that you need, but in this case we do. So what are we going to use to find our final side in our triangle? Pythagorean theorem, our good old pal Pythagoras. Coming to save the day again. And we do all that work, and B is 4. So they're asking for cotangent, which is adjacent over opposite. So our answer would be 4/3. So sine is 3/5. What is cotangent? These problems, it's always more helpful to me just to write that sentence, and then I can put it on the triangles a little bit better. Now, y'all feel good on those? Do we need to do one more? Are we all right? You want to see one more? Okay. If you don't want to write down the last one, that's fine. You can go ahead and get started. But if you want to watch one more, that's good. This last one is a homework problem, though. I just took it from your assignment. Let me write that down. So this one says the cosecant of arc cosine of root 21 over 7 is what? So I'm going to write down my statement. I know that cosine of theta is root 21 over 7. I'm trying to find out what is cosecant. Adjacent over hypotenuse. Cosecant is hypotenuse over opposite. Everybody good with the setup of that one? The adjacent, the hypotenuse? Okay. Now I'll do Pythagorean theorem. I think this has some square root simplifying that has to happen. So 21 plus b squared is 49. So b squared is 28. The 28 is 4 and 7, so that'll simplify to 2 root 7. I'll work this simplifying just because it's a little weird to do. So cosecant is hypotenuse over opposite. So 7 over 2 root 7. And we have to do root 7 on top and bottom. So I'll have 7 root 7 over 2 times 7. And my 7s are going to cancel out. And I'll just have root 7 over 2 for the answer. That was just a lot of rationalizing and square roots and stuff in this problem. But the same idea.